Okay, so this question tells us to find y equals f of x, so y is a function of x, for c of t equals 2t plus 1, comma 1 minus 9t, so that's our given parameterization, and then compute dy dx in two ways. So this is like a three-part problem. So the first thing we're going to do is kind of go backwards, right? We're going to eliminate the parameter first. So we're going to take these, so x equals 2t plus 1, and our y equals 1 minus 9t. Okay, so we're going to take both of those, or we're going to take one of the equations. I guess I'll just start with the left one here. So we're going to solve for t by itself. So we're going to subtract 1, so we get 2t equals x minus 1. So then t just equals 1/2 times x minus 1. Okay, so we're going to take that t and plug in the right side for what we see here. So it's going to equal y equals 1 minus 9 times t, but in for t we're substituting 1/2 x minus 1, okay, in for the t spot, and then we'll just simplify here, so we get y equals 1 minus 9 over 2 times x minus 1. So that is y equals 1, or I'll write 2 over 2. 2 over 2 minus 9 over 2x plus 9 over 2. Okay, so that's going to be 11 over 2 minus 9 over 2x. Okay, so now we're down to the simplest form, basically. So y equals, and I'll just rewrite it here, 11 over 2 minus 9 over 2x, which is a function of x. So step 1 is done. Alright, so that was the first part of the problem. And now we'll take this, and we'll keep our original parameterization in mind to do the second part, which is computing dy dx, so the first derivative, in two ways. So the first way that we're going to do it is the way that going through the parameterization. So the first way is to use y prime of t over x prime of t. So how much does y change over how much x changes? Okay. Another way to see this is dy dt over dx dt. Okay. So let's do that first. So our x, just a reminder, our x parameter was 2t plus 1, and our y was 1 minus 9t. Okay, so let's do dy dt first. So dy dt, so deriving that first time, it's going to be ddt of 1 minus 9t. So that's just going to be a negative 9. Okay, and then we have dx dt. So for deriving the parametric x equation with respect to t, this is what we get, and we'll just get a 2. Okay, so if we plug that into the equation up here, then we get that dy dx overall is going to be a 2. So we're doing dx, sorry, hold on. Oh, yeah. So the dy dt divided by dx dt. So that'll just be a negative 9 over 2. Okay, so that's the answer that we get from doing it the first method. And let's see if doing it the second method way, we'll get the same answer. Alright, so the second method to get dy dx is basically taking our y function, our y of f of x, and that's just we're just gonna derive it once with respect to x, whatever we got for f of x. Okay, so f of x, also known as y, turned out to be 11 over 2 minus 9 over 2x. Okay, so let's derive that once with respect to x, so we get that dy dx is equal to ddx of our function, which is 11 over 2 minus 9 over 2x. And when we do that, the constant term goes away, and we just pull out this coefficient. So that is negative 9 over 2, which matches with the answer that we got from performing it the first method way. Okay, so that's pretty much it for this practice problems video. I hope that helped, and good luck on your homework, and happy studying.